In this video, we're going to use reduced row echelon form to find an inverse of a given matrix. Here our matrix is given and the inverse is what we want. We're going to start by creating an augmented matrix with the matrix on the left and the identity matrix on the right. The goal is to get the identity matrix on the left, which would result in the inverse matrix on the right. A general strategy here is to start with the left column, work your way down, getting 1, 0, and then a 0. Then working your way up the second column, getting 0, 1, 0, and then working your way down the third column, getting 0, 0, 1. We want the 2 to turn into a 1. Do this by subtracting row 1 minus row 2. Feel free to stop the video and work out your calculations on your own. The next step, we're going to get the 1 to turn into a 0 by tripling row 2 and subtracting row 3 from that. Next, we're going to get the 3. We want it to be a 0. We're going to do this by subtracting row 3 minus tripling row 1. Now we want the negative 1 to be a 0, R3 plus R2. Next, we want the 1 to be a 1, which is already completed, so we don't have to do that. Now the 2 we want to be a 0, so R1 minus 2 times R2. Now we want the negative 4 to equal a 0, so row 1 plus 4/3 row 3. Next we want the 3 to equal a 0, so R2 minus R3. And lastly we want the 3 to equal a 1, so we're going to do 1/3 R3. This completes the identity matrix on the left, resulting in the inverse on the right. Now I want to check by multiplying the inverse times our original matrix, and hopefully I get the identity matrix. Row 1 times column 1 results in a 1. Row 1 times column 2 results in a 0. Row 1 times column 3 results in a 0. Row 2 times column 1 results in a 0. Row 2 times column 2 results in a 1. Row 2 times column 3 results in a 0. And the same thing happens with the last row, resulting in our identity matrix, which confirms that the inverse was correct. Now you have the ability to find an inverse using the reduced row echelon form.